Okay, in this video, I just want to take us a little bit further, fill in some gaps on polynomial graphing. So this is similar to the video that I made earlier, that you're looking at an equation, you're just trying to graph it from the factor form. So I'll run through it real quickly. So we know that this tells me there's an x-intercept at 0. This tells me there's x-intercept at 1, and there's a special thing happening there. This tells me there's a x-intercept at -3. So I'm going to go over to -3, put a dot, go to 0, put a dot, and go to 1 and put a dot. Now remember this, because there's two factors of x minus 1. That means that there's a multiplicity of 2 on the x-intercept of 1, which means the graph is going to ricochet when it hits that point. So it's either going to look like that or like that, depending on where it comes from. So then the next step is to figure out that this is a 1, 2, 3, 4th degree polynomial, and it's positive out the front. So that means that it's going to be opening up on both ends, or it's going to be going up on both ends. So that means I would come down, cross there, come up, cross there, ricochet there, and then end up going up. So hopefully you already have command of that idea. So now if we know that, though, we should be able to go the other way. So if I'm looking at a graph that crosses, that I know crosses here, here, and here, but it looks like this, let's say. Okay. So first of all, I know that it crosses at -1, which means x plus 1 would be a factor, because remember, factors and roots go together. We also know that x minus 1 would be a factor because positive 1 is a root. So let's be more clear about this. The roots that I've discovered are -1, 1, and 3, right? So we have x plus 1, x minus 1, and x minus 3. And because it ricochets at x minus 3, then we know that that's going to be a squared term, because that would give it a multiplicity of 2. So we could say that this equation is that graph, except for we don't know how low or high the bumps are, so we include a little a in there. So we know if we find the right a, this would be the equation for that graph. Now the way we find the right a is we'd have to know some specific point off the graph, off the x-axis. So let's say, for example, that we know it goes through the point, what is that point right there? 1, 2, 3, 4, and 1, 2, 3, 4. So it goes through the point 4, -4. So that gives us information on possibly how to find the a. So then we would replace y with -4 and replace x with 4. 4 minus 1 and 4 minus 3 squared. So when we do that, we get -4 is equal to a. 4 plus 1, of course, is 5. 4 minus 1 is 3. And 4 minus 3 is 1. 1 squared is 1. So that would be -4 is equal to 15a, which means -4 over 15 is equal to a. Oops. So that tells me that the a would have to be -4/15. So then I can go back and write my equation. Y equals -4/15 times x plus 1 times x minus 1 times x minus 3 squared. And then we're confident that this equation would be the graph of that, or the graph of this equation would be that graph. Okay? So again, it's just emphasizing this idea that x-intercepts are associated with roots of polynomials, and roots are directly connected to the factors of the polynomial. So if you know the roots, in this case we knew the roots, we could write the factors. Up here, we knew the factors, and we were able to come up with the roots, and therefore, oops, I missed that one, didn't I? That should have went right through there. Okay, so roots and factors go together.